Hey everyone, welcome to this explainer. Okay, today we are doing something literally game-changing. We're taking a huge step back to look at the big picture with our Cycle 4 integrated review. So often when we study science, it kind of feels like we're just memorizing this endless list of isolated facts, right? A term here, an equation there, all neatly filed away into totally separate mental folders. But what if I told you that true scientific mastery isn't about isolation at all? It's all about connection. We're going to explore science today not as some scattered collection of data points, but as a deeply connected, beautifully intricate web. To get our minds in the right place, I want to hook you immediately with a question. So, what do a strand of DNA and a beam of light actually have in common? I mean, on the surface, they seem like they belong in entirely different universes, right? One is the literal biological blueprint of life, and the other is just a physical phenomenon lighting up the room around you. If we rely on standard rote memorization, there is absolutely no way we'd ever put those two together. But today, we're challenging ourselves to think way beyond the flashcards. So keep that question right in the back of your mind.
Okay, let's dive right into this and establish our playing field. In this Cycle 4 review, we're pulling vocabulary from 4 foundational branches of science. We've got life science, focusing on genetics and heredity, earth science, looking at the ocean and water systems, chemistry with chemical reactions and equations, and physics, covering waves, specifically sound and light.
Now, when you see a massive list of vocabulary spanning 4 completely different scientific units, the standard approach is pretty straightforward. You just ask, can you define each term in your own words? Can you give an example? And hey, let me be super clear here, this is a fantastic starting point. Self-checking is an absolutely crucial step in the learning process. You gotta know those baseline definitions. But if we stop there, we are totally missing out on the true magic of scientific understanding. We want to take that vocabulary grind and seriously elevate it. So, how do we make mastering those baseline definitions a bit more engaging? Well, we gamify the grind. The source gives us this brilliant, highly instructional way to review vocabulary across all these branches at the exact same time. 4-branch bingo. It's super simple. Step 1, you give each student a 5x5 grid bingo card. Step 2, the instructor reads the vocabulary definitions out loud or maybe projects them on a screen. Step 3, students frantically search their cards and mark the matching terms. And step 4, the first one to complete a row, column, or diagonal wins the whole shebang. Just imagine this 5x5 grid sitting in front of you, totally filled with terms mixed from all 4 of those branches we just talked about. It brilliantly illustrates the competitive rush of mixing all these disciplines onto a single game board. You're not just, thinking about earth science for 20 minutes and then slowly switching gears to physics. No way. Your brain has to fire rapidly. You're jumping from a genetic term right to a sound wave concept in literally seconds. It's an incredibly effective and, honestly, really fun way to solidify your recall of the vocabulary before we level up our understanding. Okay, once the game is over and that baseline vocabulary is totally locked in, the real work begins. I actually want to slow down our pacing for just a second here because the source text asks a really profound question to spark a cross-branch connection. It asks, can you connect a term from one branch to a term from another using the theme information flows in structured ways? This single question is a real game changer. It moves us from a fun, rapid-fire game into this deep conceptual thought exercise. It's basically asking us to look for the invisible threads that tie the entire universe together. Let's just isolate that theme for a moment. Information flows in structured ways. This right here is our core thesis for the rest of this explainer, and it truly matters. When you realize that the universe isn't just a bunch of random chaos, but rather this amazing system where information is meticulously passed along through specific structures, everything just starts to make sense. Whether we're talking about biological data, physical energy, or chemical makeup, the universe completely relies on structured flow. Now, what's really interesting about this next bit is the juxtaposition. On one side, we have frequency, which is a concept pulled straight out of our physics unit on waves. And on the other side, we have codon, a term from our life science unit on genetics. Honestly, if you're just flipping through flashcards, you would never put these two next to each other. I mean, one is all about ripples of energy moving through space, and the other is about microscopic biological sequences. But remember our theme. Here is the deep connection. Both frequency and codon involve a specific, structured unit that carries information. Think about it. In physics, frequency carries the information that determines the exact type of electromagnetic wave, like is it visible light, a radio wave, or an X-ray. In life science, a codon is a structured unit of genetic information that dictates the specific amino acid that needs to be built. They are doing the exact same fundamental job, carrying structured info to determine an outcome, just in totally different scientific domains. And boom, that answers our very first question about what DNA and light actually have in common.
Let's shift our focus to the other branches and find another piece of this giant cross-branch puzzle. Take this definition from our chemistry unit, a balanced equation. Essentially, this is a representation of a chemical reaction where mass is perfectly conserved across the reaction. What goes in must come out. It's basically just an accounting of atoms to make absolutely sure nothing is lost or magically created during a chemical change. It's a foundational rule of chemistry, but again, it doesn't just exist in a vacuum. And this brilliantly illustrates the exact same kind of cross-disciplinary parallel. We can so easily compare the concept of a balanced equation from chemistry with the broader principle of conservation of mass and energy that we explored in earlier physics and earth science cycles. A balanced equation is, well, it's simply the chemical language used to express the universal law of conservation. The information, in this case mass and energy, is flowing through a chemical reaction in a highly structured, strictly conserved way. So, what does this all mean? The absolute crucial takeaway for you as a learner is simple. Science is a deeply connected web of concepts, not just a set of isolated facts. When you start viewing these branches through thematic links, like spotting the structural similarities between a biological codon and wave frequency, or seeing a balanced equation as just another manifestation of universal conservation, it completely transforms how you understand the material. Memorization actually becomes almost effortless, because the facts are woven into this logical, overarching narrative. It's like a giant puzzle coming together.
I want to return to this core idea one more time just to really reinforce it. Information flows in structured ways. I want this concept to leave a lasting, memorable impact on your learning journey. As you continue to review your vocabulary for Cycle 4, please don't just look at the definitions. Actively look for the structure. Look for exactly how the information is flowing. Try drawing lines between terms from totally different branches yourself, just like the source material suggests. I promise you'll be amazed at the conceptual connections you start to uncover.
Which leads us perfectly to our final thought. If structured information shapes our DNA, determines the light waves we see, and dictates the strict rules of chemical reactions, what other hidden connections exist between the universe's systems? Seriously, think about it. The web of science is vast, and we've really only just scratched the surface today. Use this thematic approach as you continue to study. Keep searching for those invisible threads, and never stop questioning how the world connects. Thank you so much for joining me for this explainer. And hey, happy studying!